1413 hours northeast of Azov Sea, a swarm of 15 Ukrainian tactical drones launches silently from a cloaked coastal facility. Their targets? A Russian coastal missile battery pointed at towns miles away. Each drone weighs under 5 kilograms, but together they form a weaponized cloud moving at 85 kilometers per hour across open field. Moments after takeoff, the Russian forces detect an unusual electromagnetic pulse. Their SIGINT operator watches in disbelief as dozens of sensor alerts flood his screens. This is no ordinary drone strike. These unmanned systems operate on a fiber optic tether network more resistant to jamming than anything seen before. Russian EW teams activate the Marina B jammer, blasting over 15 kilowatts of noise across every known military frequency, trying to sever control signals. But the fiber optic links transmit data at nearly the speed of light, silently immune to the chaos around them. The drones split into 3 attack vectors. 6 fly low, evading radar. 5 maintain altitude, delivering electronic warfare payloads. 4 ascend to 300 meters, feeding live reconnaissance to satellite uplinks. As the Russian battery scrambles to target the low-flying drones, a sudden coordinated flash. Red smoke grenades deployed by UAV-7 mark vehicle positions. Guided missiles launch from above seconds later, all precisely on target. One missile hits a fuel truck, causing a massive secondary explosion that disables half the battery. The other drones move in, releasing thermite charges on the missile launchers and antenna arrays. Within minutes, a fully operational missile silo lies in ruins. But the fight is far from over. Russian ground forces mobilize, guns opening fire on the retreating swarm. Each drone jinks unpredictably, tiny shadows against rustling wheat. The Russia commanders' radios are silent, jammed by their own desperate weapons. In this new era of warfare, every second matters. Every meter gained can shift the battlefield. And here, beneath the firestorm, the future of combat is unfolding. The Ukrainian operators know time is slipping away. Their 7 surviving drones push relentlessly toward the Russian missile battery, slipping through a haze of thermal smoke drifting over the battlefield from earlier thermite strikes. Each drone's fiber optic tether has long since released, leaving them free but exposed to the electronic maelstrom below. Suddenly, the Russian Marina B EW vehicle pivots its antenna toward incoming radio signatures. The 3 drones still dependent on conventional radio control vanish under the flood of jamming signals and immediately lose contact. Their screens go blank, their flight paths now automated with last known vectors. But the real threat isn't just the munitions, it's the impossible geometry of the engagement zone. At 27 meters per second, the swarm crosses narrow kill zones in mere seconds. Russian machine gun crews at observation posts open fire, but with reaction times lagging nearly half a second, rounds pass harmlessly behind or ahead of the targets. Inside the command bunker, the Russian commander slams a fist on the console. Their $20 million Panzer S-1 air defense system tracks the largest drones on thermal imaging, but cannot depress below -5 degrees to engage those skimming mere meters above the ground. The math is brutal. A $20 million system undone not by hardware, but by trigonometry and drone scale. The Ukrainian operators watching live feeds over the impervious fiber optic link adjust flight paths dynamically, exploiting every blind spot. A sudden flash signals a thermite charge impact on the rails behind the convoy, melting 4 rail sections in seconds, enough to bring a 4,000-ton train's progress to a catastrophic halt.
As the train accelerates, wheel spin causes a rare physics moment. Despite pushing the throttle harder, traction drops, reducing speed. The drone swarm closes in, battery power dipping below critical thresholds, calculating every meter to ensure hits count. Impact sequences unfold in rapid fire. The lead drone slams the coupling between locomotive and first wagon, a shaped charge detonating at hypersonic speed, severing the steel pin instantly. Following strikes hit fuel valves, brake lines, and ammunition cars, triggering fiery secondary explosions. Wagon 22, loaded with 12 tons of thermobaric rockets, erupts in a plasma fireball that vaporizes multiple wagons and sends shockwaves for kilometers. Within minutes, $127 million of Russian military hardware is destroyed. The air fills with the aftermath of high-tech warfare, smoke, fire, wreckage, while 60 kilometers away, Russian commanders scramble to understand how a swarm of $10 million drones, linked by fiber optic cables thinner than fishing line, shattered their defenses. This is the future of combat, where precision engineering, physics, and relentless tactics collide in silent, deadly swarms.
Modern drone warfare tactics in 2025 focus heavily on integrating swarms and heavier strike drones into operational maneuver warfare to create decisive battlefield effects. Drones now function as airborne maneuver units delivering precision strikes, reconnaissance, and electronic warfare support that enable rapid breakthroughs and isolation of enemy forces. They are no longer limited to small tactical roles, but are becoming central to combined arms operations, supporting ground forces closely with persistent and flexible firepower. Key tactical concepts include using drone swarms to bypass or overwhelm enemy static defenses, opening multiple axes for ground advances, employing drones to isolate enemy units, preventing repositioning and reinforcements, setting conditions for operational exploitation. Integrating drones with armored and mechanized forces for constant reconnaissance, suppression, and strike, effectively turning formations into combined air-ground units. Exploiting low-altitude contested airspace, air littoral, as a new maneuver domain to achieve flanking and attack axes beyond traditional fronts. Developing drone operational doctrine that views drone-enabled campaigns as central to turning tactical successes into operational and strategic outcomes. Using heavier strike drones to provide decisive firepower akin to historical armored or air support breakthroughs. Overcoming enemy electronic warfare through technologies like fiber optic tethering and pre-programmed autonomous flight to maintain control and intelligence links. Capitalizing on the limitations of traditional air defense systems, struggling to engage highly maneuverable, small, and erratically moving drone targets at close range. These doctrines and innovations are transforming drone operations from reconnaissance and minor strike roles into critical enablers of maneuver warfare, capable of rapidly destroying or disabling enemy formations, supply lines, and infrastructure to enable larger ground force advances. Modern drone warfare in 2025 is transforming battlefield dynamics by integrating drone swarms and heavier strike drones into operational maneuver warfare, rather than limiting drones to reconnaissance or minor strike roles. These tactics enable rapid, lethal effects at scale by bypassing static defenses, isolating enemy units, and supporting fast-moving ground forces with persistent close air support, essentially turning formations into combined air-ground units. Key elements include heavy drones delivering decisive firepower alongside infantry and armored units, enabling operational breakthroughs. Drones controlling contested low-altitude airspace, air littoral, to open new flanking and attack axes. Continuous stream of real-time intelligence from dedicated drone brigades to accelerate decision-making and exploit enemy vulnerabilities. Overcoming traditional air defense challenges by employing small, agile, and erratically moving swarms that are difficult to track and engage. Use of advanced technologies such as fiber optic tethering to maintain control links despite enemy jamming. The importance of doctrine and operational art that integrates drones to convert tactical victories into strategic successes through persistent pressure, disruption of command and rear areas, and creating mobility corridors for ground forces.